All right, this is number 7 from the 2010 Form B AP Physics B exam. We're looking at the photoelectric effect. We've got data taken here. A teacher giving us this graph shows frequency versus stopping potential, or stopping potential versus frequency for the photoelectric effect. We want to know the work function of the metal itself in electron volts. And so recognize that that work function, phi, is always going to equal the minimum amount of energy required to eject photon of specific frequency f. So often referred to as f naught, the threshold frequency, meaning any frequency of light coming down on it less than that frequency, electrons will not be emitted. Anything more than that, electrons will be emitted with kinetic energy. So that anything more than that, if the electrons have a kinetic energy, means we're going to need some stopping potential to stop those electrons. Really, if we just look all the way over here, we see F naught. F naught's going to be the x-intercept. Looks like it's about 4.5 times 10 to the 14 hertz. So my work function is going to be h times that. We want our answer to be in EV. So I'm going to use the value of h that's given in EV, which is 4.14 by 10 to the negative 15 EV seconds. That's going to get multiplied by that threshold frequency of 4.5 by 10 to the 14 hertz. And you're going to get 1.9 EV for your answer. That is going to be the work function. Now, we want to know if the stopping potential is 1.5 volts, what's the maximum kinetic energy of the emitted photon in, again, EV? Well, recall, the incident energy, HF, must always equal the work function plus kinetic energy that the object has, or maximum kinetic energy for the electrons. We're looking for KE. So your KE will be equal to the incident photon minus the work function, meaning how much energy is getting put in minus the amount of energy it requires to take it out. That whatever's left over will be kinetic. Well, we already know the work function. We figured that out. It's the HF part that we got to recognize now, because this is the photoelectric emission up here. So we know that when we have a 1.5 volt stopping potential, we're going to get 8 by 10 to the 14 hertz as the, not the photoelectric emission, I'm sorry, that's the frequency of light required to get photoelectric emission. So we're going to use, once again, H as in the EVH, 4.14 by 10 to the negative 15 EV seconds. We're going to multiply by the frequency required to get that stopping potential, which is the 8 by 10 to the 14 hertz. And we're then going to subtract our 1.9 EV. And we get 1.4 EV left over. That is the answer. And there are probably a few alternate solutions for this, but I think that's the most straightforward way. C. What is the wavelength of light that will eject photoelectrons with the maximum kinetic energy we just found? So what wavelength of light is associated with this stuff? We could go ahead and redo the energy, and I think it's hc over lambda maybe, if I recall correctly, but I think there's an easier way. If we know, we recognize that the speed of light in a vacuum is lambda f, then lambda is going to be the speed of light over the frequency. The speed of light is 3 times 10 to the 8 meters per second. The frequency is the frequency of light causing photoelectric emission, which is the 8 by 10 to the 14 hertz. I like this. I think this is the easiest way of doing it. So that's why I'm doing this. And you're going to get 3.75 by 10 to the negative 7 meters. There it is. And finally, D, what would the wavelength of light be that will eject the photons with lower kinetic energy? Really, it's just a fancy pants way of saying, will the frequency needed go up or down? Will the wavelength go up or down? Well, if we wanted to have less energy at the end, we need to have less incident energy. Incident energy is related to F. So if F needs to be smaller, F is inversely related to wavelength. The wavelength needs to be longer. So it will be longer than that found in part C. And your explanation is going to be pretty much what I just said, but you're going to write it down and you're going to use equations. Okay, that's it for number 7. Thank you.